this lesson, we'll have a high-level look at what 2FA is and how it works. For a normal login to a system, you'll supply a username asserting who you are and an additional piece of information or factor, such as a password. In the world of authentication, factors include something you know, like a PIN or password, something you have, like a security badge or USB key, and something you are, like a fingerprint, retinal scan, or facial recognition. I think this is a bit of a misnomer because I'm not my fingerprint, but it's typically based on some biological feature that links to you. It can include voice recognition. For our solution, we'll install an app on our server that will generate a random, time-based, one-time password or TOTP. There's an algorithm that generates the TOTP, and the TOTP is relatively short, but only good for a short time. It's typically a 6-digit numeric or number-letter combination. This is an incredibly short password and could easily be cracked by exhausting all possible combinations from 0 to 999,999 by a computer. The thing is, it's only good for a short time, typically 30 to 90 seconds, and the number of attempts is limited. The app will synchronize with an external app on a phone or similar device. Once the two devices are synchronized, they independently generate the same number in the same time frame based on the shared settings for the algorithm. When you go to log in, you'll enter your username and password and then be prompted for the TOTP generated by your app. If they match, you're in. If not, you'll have to try again. In our case, we'll be authenticating using a certificate and its password. We'll then be prompted for our TOTP. You'll see exactly how this is set up in upcoming lessons. Once you have the TOTP app installed and understand how it works, you can protect other resources like your primary email address, social media accounts, or financial accounts using the same app. I recommend looking into whether your desired institution offers it and setting it up where possible if extra security is important to you. I use Proton Mail for my personal account and have set up 2FA for it, for example. Now you understand what 2FA is and how it works. See you in the next lesson. In this lesson, we'll look at a few of the apps you can use to prepare for enabling 2FA. There are many free and paid options. This is an article on PC World about what are the best 2FA solutions. We're looking at software options. These are applications you can install on your phone. They're generally available for both Android and iOS or Apple devices. Google Authenticator comes out on top. LastPass Authenticator. This is the one I use. They have a free and a paid option. I get the paid option because it's priced very reasonably. Microsoft Authenticator and Authy. Wherever possible, you'll want to choose one and stick with it. I can tell you from experience, it's kind of a pain to search through them looking for the one you need for a particular login. I do like LastPass Authenticator. It does allow you to back up and save across devices, so if you get a new phone, you can easily transfer your data over to that. That is not the case with Google Authenticator. I got a new phone and had to manually redo a lot of accounts. So I do like LastPass for that reason. The paid version is priced very reasonably at $3 per month if you're billed annually, or $36 once a year. And I like to support great work if the price is reasonable. Along with providing an app for 2FA authentication, LastPass is also a password vault. Just be sure you secure it with a good passphrase and enable 2FA on your LastPass account itself. The free version will do everything you need for enabling 2FA on your server, though. Once you sign up for an account and confirm it using the email that you'll receive, you'll be good to go. You can download the app, install it to your phone, log in with your credentials, and then when you're ready, you'll scan the quick response code or QR code from the 2FA app on your server. The phone will recognize this code and synchronize with the server so that the algorithm on the server and the algorithm on the phone generate the same code in the same time frame. That's it for adding an app to your phone. See you in the next lesson. In this lesson, we'll configure the server to be able to support 2FA. We'll be installing an application called libpam Google Authenticator. Although supplied by Google, Google will not receive any data from your server. This is a standalone application. Before starting, be sure the font size supported in your terminal emulator is relatively small. If you don't, the QR code will not fit and won't scan properly. If this happens, you'll have to type the long secret key into the app manually. It's a bit of a pain, but doable. Install the app by typing sudo apt install libpam-google authenticator. Then run Google Authenticator by typing google-authenticator. It asks, do you want authentication tokens to be time-based? Select yes. And here's our QR code. And you can see how it kind of runs off the screen. So if you can't fit it on your screen, you have to type this long code in there, and that's not fun. Be sure to copy your emergency scratch codes and keep them in a safe place, like on an encrypted USB drive. When it asks, do you want to update your Google Authenticator file? Type Y for yes. Do you want to disallow multiple uses of the same authentication token? Yes. I leave these at default and select yes, these settings for generating the tokens and the courtesy times. It's saying we could be vulnerable to brute force. We aren't because we use fail to ban and we don't allow password authentication anyway. But we will enable rate limiting. So type yes. Give us an additional layer of security. Now we'll configure SSH to use Google Authenticator during authentication. Assuming you'd followed the process for managing SSH using a configuration file in etc ssh sshd-config.d, add the following lines to that file. Use PAM, yes. Challenge response authentication, yes. Authentication methods, public key, and keyboard interactive. Again, the keyboard interactive is to allow us to put in the key, the one-time password. Restart SSH. Then we'll modify PAM to accommodate 2FA for SSH logins. We'll make a copy of the PAMD SSHD file, and then we'll edit the PAMD SSHD file. We'll comment out the line that says @include common auth, and we'll add the following lines. You can see when it adds lines, it automatically comments them for you, so be sure to uncomment the one that you want to actually work. So the new line is auth required, pam_google_authentication.so, and then a comment to tell us what this line is for. Now we'll test to make sure authentication works. And we're prompted for our verification code. And our verification code works, and we've authenticated using MFA. Good job. In this lesson, we're going to learn how to get on your server if your phone is lost, damaged, or just quits working. The obvious and easiest solution is to use one of your scratch codes. So if you kept those handy, and you can find them when you need them, you'll use one of those. So we'll SSH to our server, put in the password for our SSH key, hopefully successfully. And for verification code, we'll paste in one of the scratch codes. And we're in. Now when you have your new phone, you could just run Google Authenticator again, and it will generate you a new code that you can put into your new phone. So that was pretty easy and straightforward. What if you lost your recovery codes? Oh no, that could never happen, right? Well, it has. It's happened to me even, of course. So yeah, if you don't have access to your recovery codes, you'll have to get console access to your server somehow. In DigitalOcean, under my server, I can click on Access Console. That'll bring me to this web-based console where I can log in. And my password is crazy. So I am not going to type it, I'm going to copy it in. And I'm in at the console. Now how do I get back in with my app? So if you have a new phone, you could just run Google Authenticator here and you're all set. But if you need to get in with your existing codes for some reason, you can cd, make sure we're in the home directory, and cat Google Authenticator. And this first line here is the line you'll have to put into your phone. So you would click Add for add a new site in your phone, in your application. And when prompted, instead of scanning a code, you would type this in, and that'll get your app synchronized with the server. So if you don't have access to your old phone, it's a good idea to just rerun Google Authenticator and scan the new code. So that's it for recovering from a lost, stolen, or broken phone. Good job. See you in the next lesson. In this lesson, we'll learn how to use an alias to SSH servers we go to often. When you SSH to something at the command line in Linux, you have to type something like SSH username at IP address, or SSH Theo at 192.168.254.127, for example. Along with the username and IP address, you may have to type some additional options, such as port number if you're using a port other than 22. Wouldn't it be cool if you could type much less and get the same SSH connection? You can by using a config file in the .ssh folder of your home directory. When you type SSH, one of the places SSH looks for instructions is a file called config in the .ssh folder of your home directory if it exists. Just navigate to the .ssh folder in your home directory, type cd /.ssh, and add a file called config with the following content at a minimum. So right now we don't have a config file. So we'll make one. And in that file, we'll want these entries at a minimum. Host is the name for this. We'll just call it Ubuntu 1. You can name this anything you want, but it's good that you use a name that makes sense. So typically it's something similar to the host name of the server you're trying to get to. Tab in and type host name, and then the IP address of your server. User is the username you want to log in with. So then you just type SSH and the host name you just defined. And you're in. This seems like it isn't a great benefit if you're only accessing one server with SSH. If you have 20 or 10 or even 5, it can be worth your while to have shortcuts to them though. If you use the same settings for many servers, you can have a wildcard entry at the bottom for those common settings. So if we type host *, and we always use the username Theo for our servers, we can just put that down here, and you don't need it for each of the entries. Or if you use port 2222 as a custom port for all of your servers, you can define that here. If you want some of your hosts to use their own settings, you can specify that setting under the host. So in this example, any other hosts besides Ubuntu 1 would use port 2222. They would also use the username Theo. Ubuntu 1, however, because we defined a port here, would use port 22. And we'll prove that that still works. There we go. So even though we defined port 2222, we defined port port 22 just for this host. That's it. Now you understand how to define aliases for the SSH config file. Good job.